Central tendency is about finding one number that represents a set of numbers or a collection of numbers. It reminds me of an old saying that if you stand with one foot in a bucket of ice and the other foot inside of a bucket of boiling water, on average, you feel fine. And of course, that's not the case. So that shows us the limitation of central tendency. But it's all about, if you have a whole bunch of numbers, finding one number that best represents those numbers. And we've got three main ways to do that: the mean, the median, and the mode. So we'll find all three of these for a collection of numbers. Let's say I've got 1, 1, 2, 3, 5, and 8. The mean is what you get when you add all the numbers together and divide by the number of numbers. So the mean would be 1 plus 1 plus 2 plus 3 plus 5 plus 8, all divided by 1, 2, 3, 4, 5, 6. So it would be 13, 16, 18, 19, 20 divided by 6. And 20 divided by 6 is 3.3. Well, that 3 is repeating. So the mean of all these numbers is what you get when you add them all together and divide by the number of numbers. We add these numbers together, we get 20. There are 6 numbers. The mean is 20 divided by 6, which is 3.3. Notice the mean is quite a bit lower than the top number, quite a bit higher than the bottom number. The median is what you get when you put all of the numbers in order and select the middle number. These numbers are already in order, but notice I have 6 of them, which means I have an even number of numbers. So there's no middle number to select. So I select the 2 middle numbers and I take the average between them. 2 plus 3 divided by 2 is 5 divided by 2, which is 2.5. So my median, that is my middle number when I put them in order from lowest to highest, is 2.5. Because there's actually not one middle number, there are 2 middle numbers. And I average the 2 middle numbers. The mode is the most common. In this case, I've got more 1s than I have of anything else, so my mode is 1. The mode is most common. The median is the middle number, or the average of the 2 middle numbers if they're put in order. And the mean is what you get when you add all the numbers together and divide by the number of numbers. So 3.3, 2.5, or 1 are all candidates as our best representative of this collection of numbers. Let me do one more example real quick. The mean is the sum of these numbers. Divided by the number of numbers. So it is 87 divided by 5. It is 17.4. Now, 17.4 looks rather typical amongst these numbers. The median is the center number when they're all in order. Let's check to verify that they're all in order. They go lowest to highest. There are 5 numbers. That's the middle number. So the median is 18. And the mode, the most common number, there is no mode. See, sometimes there'll be no repeating number, in which case you can say there is no mode. When would you use one as opposed to the other? The median is a good representative quite often because you don't run into an issue where an extreme number, one that's much higher than most of them or much lower than most of them, it ends up not affecting the median. We call that extreme number the outlier, and the median is not affected by outliers. However, sometimes you want to include all numbers, including the outliers. So, in which case you wouldn't want to use the median because it completely ignores it. Give you an example here. So let's say our numbers were 2, 3, 4, 5, 20, or 2, 3, 4, 5, 6. Both of these sets of numbers have the same median. They have a median of 4. This one will have a much higher mean because it includes the 20 than that one. A problem with the median, in addition to ignoring the extreme numbers, is if you have bimodal data, meaning let's say you've got a bunch of 2s and a bunch of 8s, and let's say you've got one more 8. This has a median that's way up at 8. And this has a median that's as low as 2. The median of this is 8. The median of that set is 2, but both sets are rather similar. So their central tendency number is quite different. Their representative is quite different if we use the median. And in this case, it would be more appropriate to use the mean. That's why we have 3 different ways of measuring central tendency. There are times when one is more important than the other, or more appropriate, I should say, than the other.